This is an introduction to the normal distribution. It's a really interesting thing. It happens like in lots and lots of different scenarios with lots and lots of different variables. You've seen the normal distribution in action before in your own life. An example of the normal distribution is people's heights. So if you line up on photo day, for instance, and the teacher says something like line up shortest to tallest, there are a couple of people in the class that are fairly short, so they go right down to this end. There are a couple of people who are very tall, and they go down to this end. But then the majority of people are like about the same height. They're all sort of clustered around what the middle of the heights are. They're all about the same height, and they're just kind of measuring up against each other. Okay, so the normal distribution is essentially that idea that most people tend to cluster around the middle, and then there are a couple of tall people over here, a couple of short people over here. That happens for people's heights, it happens for people's weights, it happens for people's IQs. There's a whole bunch of naturally occurring phenomena where this takes place. And now what we're currently looking at is called a normal distribution curve or a bell curve. Now this is the bell curve of the average men's heights. Now it takes a little bit of interpretation, so it's a bit tough to understand, but bear with me here. Now the average height of a male is 178 centimeters. It also happens to be the median height. With normal distributions, the mean and the median are equal to each other. And this is represented by this little line here in the middle, 178 centimeters. Now that line doesn't have to be there, but that's just showing where the median is. Now, the standard deviation of male heights is 10. Now, we'll talk more about that in a minute, but that's just how spread out the heights of males are. Now, using this curve, we're really interested in the area under the curve. The area under the curve is going to tell us something really special. So if you look down, right down here, I might find out the probability that if I choose a male at random, that they'll be between 170 and 180 centimeters tall. Okay, 170, 180. Okay, so you can see that we've got a line here, 170, we've got a line here, 180. Now the area underneath this curve, like the integral that you've learnt about in the past, the area underneath this curve tells us the probability that a randomly selected male will be between the heights of 170 and 180. And our little calculator here has done it for us. It's 0.3674. There's a 36.74% chance that if I walk out and grab a guy at random, he's going to be between 170 and 180. And I can do this for any number of values. So I could say, okay, what's the probability that someone's between 190 and 210? Oops, 190. Okay, so the probability that someone's between 190 and 210 is given by this area under the curve, and it's 11.44%. It's fairly low. Or what if the probability that someone's over 2 meters tall? Okay, very, very small. The probability that someone is, let's increase that to like 300. Now, the probability that someone's over 200 centimeters tall is about 1.39%. Now, theoretically, the normal distribution, this line, never, ever, ever, ever touches the x-axis. It goes on and on and on forever. Now, obviously, humans aren't like 10 meters tall, but that's just sort of theoretical. So if I type this in here, 400, you can see the probability that someone's between 200 and 400 is still the same as the probability that someone's between 2 and 300, but it has, if we go to like 20 decimal places, it's increased slightly. That's the normal distribution. The probability is the area under the curve. I'm going to do like a little sketch of a normal distribution and mark up a few little key points here. Now, this is my normal distribution. The mean of my normal distribution is always here. And it's represented by this, mu. In the instance of my heights, that was 178 centimeters, but that can obviously be anything depending on what the thing is that we're measuring with our normal distribution. And the standard deviation is given with this, sigma. So we have mu there, which is our mean or median, and we have this one, which is sigma, which is standard deviation. And in the example I just gave, the standard deviation was 10 centimeters in the example I gave. Okay, I just want to show you really quickly one more thing before we sort of finish off this one. It's just an introduction. Okay, so the standard deviation is kind of useful here. So if I type in some specific numbers here, 168 and 188, what I've done there is go one standard deviation to the left of the mean and one standard deviation to the right of the mean. The mean's about there, and I've gone one there. We get this number here, 68.27. So what that means is that 68.27, or we can just sort of round it, I suppose, to 68.2. 68.2% of people are within 1 standard deviation of the mean. So you can see here 34.1 are 1 standard deviation above the mean, 34.1 are 1 standard deviation below the mean. And then we can go up another step. Let's try 2 standard deviations. So let's go 158 to 198. You can see that about 95% of people, 95.5% of people, are within 2 standard deviations of the mean. And you can see about 99.73% of people are within 3 standard deviations of the mean. So that gives you a neat little sort of benchmark for standard deviations. And just the last thing I need to talk to you about, I'm going to talk about this in greater depth in a future video, but the last thing I need to talk about is the standard normal distribution. Now, the standard normal distribution, it's very straightforward. It just has a standard mean and a standard deviation, and those numbers are a mean of 0 and a standard deviation of 1. So a mean of 0 and a standard deviation of 1. This is what's called the standard normal distribution. It's kind of useful because we can now say that from -1 to 1 is 68.27. So because it's got standard deviation of 1, we can do that. We can say -2 to 2, 95% of stuff appears there. And from -3 to 3, 99.7 of a percentage of stuff lies between there and there. That's all we really need to talk about for now. The standard normal distribution actually gets used to calculate your final year 12 grade, so it's kind of an interesting idea. Talk some more about that in a future video.